In 2022, this question was very important because not only was it worth 8 marks, which is more than 10% of the paper, it was also particularly problematic when it came to part B, where the question, quote, proved the challenge and there were many blank responses. With this in mind, make sure to stick around to the end. The trick with these wordy differential equations is to cut through the fluff, because that allows us then to define the equation mathematically, which in turn allows us to break down the process in a much simpler way. Cutting through the fluff here means focusing on a few points. 1. That we have an amount x that is increasing. 2. That amount is increasing relative to time, which gives us dx by dt is equal to kxe to the power of negative 0.1t. 3. We're given an initial condition that x equals 20 at the beginning of the reaction. So then, we've got 3 ingredients to work with, but the thing is, we now have to present this mathematically. As you may have seen in a previous video I did on differential equations, there's basically 3 steps to solving them. A. Separate the variables. B. Set up the integrals. And C. Solve said integrals and rearrange. To separate the variables here, simply bring x over to the one side and dt to the other side. Next, we need to set up the integrals. As 20 is our initial condition for x, and 0 is the initial condition for time itself, we can set up the integrals like this. From here, it's just basic integration. We can say that the integral of 1 over x is ln x, and then the integral of e to the power of negative 0.1t is e to the power of negative 0.1t divided by 0.1. Plugging in our boundaries now, we then get ln x minus ln 20 is equal to negative 10k e to the power of negative 0.1t minus 10k. This then gives us a final answer of ln x is equal to 10k times 1 minus e to the power of negative 0.1t plus ln 20. As stated before, this part is critical. As the examiners noted, part B was challenging and had several blank answers. At its core, this is really just a limit question. You just have to find what x tends towards as t gets bigger and bigger and bigger. And the way to start here is simply by using the equation that we just found. But there's an issue. Can you see it? Let's pause the video and see if you can find it. We're told that we have to find the value of k, and so we plug in both x equals 40 and t equals 10 in order to do that. This gives us a value of k is equal to 0.1096542694. As a very important disclaimer, from now on, I will be referring to this decimal as 0.11, purely for speaking purposes. However, technically this is not 100% correct, so just know when I refer to 0.11 from now on, I'm actually referring to 0.1096542694. 654,269,4. So then, what does our equation become? It becomes ln x is equal to 1.1 times 1 minus e to the power of negative 0.1t plus ln 20. Now that we've got our equation set up, we can refer to the original premise of the question. What happens to x as t becomes bigger and bigger and bigger? In other words, what happens to x as t tends towards infinity? Well, as you can see, as we tend towards infinity on t, e to the power of negative 0.1t will tend towards 0, as we will have e to the power of an infinitely small number. What happens to our original equation then? Well, e tends towards 0, so 1.1 times 1 minus e to the power of 0.1t just becomes 1.1 times 1. With this in mind, we get ln x is equal to 1.1 plus ln 20, which when solved gives us x is equal to e to the power of 1.1 plus ln 20, which equals 59.9.